and welcome to Movie Time with Rodrigo Capelli. And now for your host, Rodrigo Capelli. Thank you. Well, thank you so much. Thank you for that warm ovation. Yes, Movie Time with your favorite actor, aka favorite teacher, aka favorite human altogether, Rodrigo Capelli. That's right, we have a great movie for you guys, and you guys are always asking about movies. So here's a movie. It's a great movie. This one's probably going to win a lot of awards, and that movie is Add and Subtract Rational Expressions. Yes, I know you were enthralled about this. Please get these notes out, and before I get into the heart of the notes here, I want you guys to do 3 problems on your own. Do these 3 guys, then pause the video, then press play. Okay? So go to pause the video, do these 3 problems, and then we'll go over the answers. Okay, so you guys did those problems, and hopefully you got this stuff right here. 4 over 2, 2 over 1 equals 2, etc., etc., etc. Here we had to multiply the top and bottom by 3 to get a common denominator 6, multiply top and bottom by 2, common denominator 6, and then just put it all together in the numerator, 3 plus 2x over 6. Same thing over here, multiply top and bottom by 3, top and bottom by x. Your LCD is 3x, and you got 3 plus 2x over 3x. Okay, so let's take a look at the next step here. Upshot. Upshot essentially means summary or conclusion. To add rational expressions, you must find the... Well, let me call on you guys. Let's see who we got here. I want to hear from Brian Cruz. What do you think, Brian? Least common denominator? Is that what you say? Nice, correct. Least common denominator. Yes, you guys already knew that. You already knew that. You learned that back in, I don't know when, 4th, 5th grade, etc. However, let's go back to some background information you need to know to do these. So there's just a multiple and a factor. All right, let's say multiples of a number a. The number a multiplied by an integer. Okay, so multiples of 8 would be 8 times 1, 8 times 2, 16, 8 times 3, 24, etc., 32, 40, and it goes on and on and on. Okay, factors of the number a. Numbers that multiply to make up a. For example, let's say if a is number 8, what is to make up a? So we got basically 1 times 8. We have 2 times 4, and 8. So that's basically all the factors of 8. Okay, this is important to know because sometimes we talk about the least common multiple, which would be a multiple. I'm sorry, right here. A least common multiple and a greatest common factor. All right, so this is a factor right here. When we talk about GCF, that's a factor. When we talk about least common multiple, we will talk about this stuff right here. Okay? Okay, trying something new here. Listen to those first few clips, and my voice sounds pretty scratchy. I don't know what's going on, but I got a new mic here. I think you might need to turn the volume up a little bit. But yeah, we're gonna record it from here, and hopefully it sounds better. But I'm not gonna re-record those guys because frankly, I don't feel like it. So let's just power through, move along. Let's talk about LCD, least common denominator. All right, basically the LCD is the same as least common multiple. So LCD is the same as the least common multiple. Again, multiples are these guys. All right, so same as LCM. So we're right here, but just using fractions. So when you're talking about, let's say 1/3 and 1/4, what is the LCD of that? Well, the LCD of that is 12. All right, you would say LCD because you're talking about fractions. However, if you just look at 3 and 4 denominators, what is the least common multiple of 3 and 4? Well, in that case, you would just say LCM because you're looking at numbers, and you look at the multiples of 3, 3, 6, 9, 12, 4, 8, 12, etc. What's the least common multiple, well, 12 would be the least common multiple. That would be between 3 and 4. Notice that the common multiple is also 24, but it's not the least common multiple. And when we do these fractions, we want to use the least common multiple or LCD because it's just going to make life easier. Okay, let's try a problem here. I do, and then you guys will do this one. So let's add these fractions, and we got to find the least common denominator, LCD or LCM. But since fractions, I'm going to say LCD. I'm going to just look at this, and I say 6 and 5. I'm just looking at the numbers, and so the LCD of 6 and 5 I know is 30. I'm just thinking in my head. If you want to do this, if you want to list it out, you list all the multiples of 5 and list all the multiples of 6 and see what they have in common. You can do that. And then I need to pick the highest power of each variable. So I have an x squared and a y squared. All right. So here we got our, I'm going to write it, let's see, I'm going to write this down here. 1 over 6x squared. Give myself a little bit of space. 4x over 5y squared. And I want to get to 30x squared y squared. All right, what do I need to multiply 6x squared top and bottom to get to 30x squared y squared? And to do that, I need to multiply by, on this one, 5y squared. And what I do to the top, I do to the bottom. That's not changing the fraction anyway. All right, so that's going to make the top 5y squared. And what do I need to multiply this one top and bottom to get 30xy? That should be a squared, right? Yes, it should. And so what do you multiply top and bottom? So 5 times what is 30? Okay, 6. And then I need to put an x squared in there. What I do at the top, I do at the bottom. And so it looks like I got 6 times 4, or 4 times 6 is 24x cubed. All right. These are not like terms, but I can totally write it in one fraction as 30x squared y squared. And I'm just going to write 5y squared plus 24x cubed. All right, good times. All right, we do. Or how about you do? Right now, go ahead and stop the video and just do this problem and check your work. All right, really try it on your own. See if you can do it without any help, and then check your work. Alrighty, so you should have gotten to this point right here. My LCD, if I look at it, is basically that times that. That's off. Sometimes your LCD is both denominators multiplied together, and we got 8x squared y. So what do I need to multiply this equation, this fraction to get the denominator to be 8x squared y? Well, let me call on you guys again. And whoever gets this right is going to get a Jolly Rancher. That's right. This is going to be a good. Everybody likes the red ones. All right. So let's see. What am I going to multiply top and bottom? And Barrett Stone, what is the answer? Did you say 2y? Correct. Wow. 2y is correct. Yep. Multiply top and bottom by 2y. Now, since you are not here to claim your prize, I will eat it myself. And I know that, seeing that we're such good friends, that you would want me to have it anyway. So give me a second. Pop this in mine. That was really good. That's a fresh one. Okay. So then we got, right here, we got 10y squared. Okay. And let's do this one. What are we going to multiply top and bottom by? 4x squared. That's going to give us 12x cubed. All right, and then again, we cannot combine the numerators, so we're just going to write 8x squared y 10y squared minus 12x cubed. Beautiful. And that's our answer. Hold on a second. No, we're good. We're good. We could simplify this, but we're going to leave it as such. All right. So I'm not going to simplify. All right, next page. Flip the page. We're going to get to the least common multiple of two numbers. We're going to learn how to do this for, let's say you want to find the least common multiple of two big numbers, okay? Let's say 46 and 24. All right, well, first thing you're going to do is you're going to do this thing called prime factorization, okay? So do a prime factorization tree. So you write 46, and then usually I want to write 46 as a product of primes. Prime numbers are numbers that are multiplied by 1 and itself. So like 2, 3, 5, 7. 8 is not prime. 8 is a composite number. You can have 1 times 8 or 2 times 4. So let's break it up into primes. So when I see an even number, I like to break it up into 2. And let's see, we got 2 times 23. And can we keep going? Well, 2 is prime, 23. Boom, also prime, done. Let's move on to 24. Okay, so we're going to do 24. It's even, so I'll just do 2 times 12. I bring down this 2, and I got 2 times 6. Bring down the 2's, and I got 2. 6 is 2 times 3. All right, so what we got here is we got, I'm going to write these numbers and a colon, and I'm going to list the prime numbers. So we got 2 times 23, that's 46, and 24. I'm going to write each factor once with an exponent. So I'm going to write 2 cubed times 3. Okay, so that's 46 and 24. My least common multiple is every different factor listed once to the highest occurrence or highest exponent. Okay, so my least common multiple is every factor listed once. So do I have a 2? Yes, I do. 2 to the what power? What's the highest? Cubed. Okay, what else I got? I got a 3. Okay, so let's do that. So 3, and there's not a 3 here, but I'm going to list the 3 anyway. 3 to the first power, and the other factor I have is 23. All right, and if I multiply that all together, it looks like my LCM is 2 cubed times 3 times 23, and it is 552. 552 is a multiple of 46, and it's a multiple of 24, so it will 552 divided by 46 will be an integer. Yes. And 552 divided by 24 is also an integer, 23. Okay, so if you want to check your answer, how did you get the least common multiple, then you can divide the least common multiple by the 2 numbers, and you should get an integer. Okay, so this is a way to find the least common multiple by prime factorization. All right, let's do an example. Let's say we got 45 and 35. All right, so what I'm going to do is I'm just going to start with the numbers, and I'm going to do the prime factorization tree. All right, so cool. So 45, it's not even, but I do know 5 goes in there. And we got 5 times 9. All right, I'm going to bring 5, and then I got 3 and 3, and boom, I'm done. Okay, and 35. Okay, so 35 is 5 times 7, and done there as well. All right, so I'm going to write both monomials because these are made up of numbers and variables, so it's just a monomial. 45xy cubed. Note this one's slightly different than that one because this one has some monomials and variables in there. And I'm going to list all the prime factors. So 45 is 3 squared, 2 3's, times 5 times x times y cubed. All right. 35 x cubed yz is 5 times 7 times x cubed times y times z. All right, my least common multiple of these with the variables would be, I'm going to take one of each factor and take it to the highest power. So I have a 3. So even though this one doesn't have a 3, I'm going to include my least common multiple, and I have 3 squared. All right, what else do I have? I have 5. Both of them have a 5, but I'm just going to take one sort of the highest exponent, which is both of them are to the first power, so times 5, right? Notice I did not write 5 squared. And what other factor do I have? I have 7. Okay, so I'm going to write that. Even though this one doesn't have a 7, I write it in there. I have x. What's the highest power x I'm going to include? X cubed. And y, I'm going to take the highest power y cubed and z. Okay, so it looks like my LCM is eventually going to be 9 times 5 And 9 times 5 is 45. 45 times 7 is 315, I believe. Oh my gosh. That's amazing. So we got 315 x cubed y cubed z. That's the least common multiple of these two monomials. And again, I can check. I'm going to go ahead and divide 315 by 45, even number, or just the whole number, shall I say. And 315 divided by 35, good times. Sweet. All right, so that's the LCM. All right, let's move on to how to do it when you have a fraction. Haha, you guys got rickrolled. You didn't know it was coming. Haha. Rick Astley. I love Rick Astley. Okay, well, let's get back to math here. So now we're going to add and subtract rational expressions. So now we're going to look for LCD, okay, which is basically LCM, but with fractions. All right. Well, let's get through the first step. So find the LCD using the system above. So we're going to do the LCM. Well, I got a question for you guys. What is the LCD of these two monomials? What is the LCD of these two monomials? Let me call the cards here. Calling cards. Let's see what we got. And this person's also going to get a Jolly Rancher. We have a blue one here. Okay. And let's go top of the... No, let's go in the middle somewhere. Ava Fry, what is it? Did you say 315 x cubed y cubed z? Correct. Nice job. Yes. It just so happens that I made the notes to be the same LCD as that one. So we just did this process right here. So our LCD is 315 x cubed y cubed z. Okay? Ava, I know since you're not here, you would want me to have this Jolly Rancher because, you know, being one of your favorite math teachers this year. Yeah. Give me a second, folks. Oh, that's a good one. Okay. Ooh. Yeah, that gives me a little burst of energy. All right, so let's get going with the LCD here. So here's what I want to do. So I have my my denominators. I got 45xy cubed. And I'm going to go ahead and list the factors that I have above. 3 squared 5 times x times y cubed. And I have 35x cubed yz. And that equals 5 times 7 times x cubed times y times z. Okay, so so my LCD is, I'm going to write it right here. So space things out the way I'm spacing them. Okay, so I'm going to do this thing called, I'm going to multiply here. I'm going to color code things. And I'm going to call this missing factors. Okay, and this all needs to equal my LCD, which my LCD is 3 squared times 5 times 7 times x cubed y cubed z. And I try to squeeze it in there. Where did I get that? It's right here. Okay, this equals that, right? Okay, so I'm going to write this one right here. So 3 squared times 5 times 7 times x cubed y cubed z. Now, you may not need to write all this stuff later on, but do it this time and you'll see what I'm talking about. All right, so what do I need to do to multiply this to get that? Well, I am missing times 7. Okay, I'm missing a 7. I have an x and I have an x cubed, so I'm missing an x squared. Okay, and I have I don't need a y. All right, I don't need a y, and I need a z. Okay, so I got 7x squared z. So let's see, I have a 3 squared, I have a 5. I need an x squared and y cubed and z. Good times. All right, this one. What am I missing here? What am I missing in that one to have it look just like this one? All right, well, I'm missing a 3 squared. Okay, and I am missing, I'm not missing a 5. I have a 5. I have a 7. I have an x cubed. I have a y, and I have I need a y squared. And I have a z. So I got y times y squared is going to be y cubed. Okay, so all right, that part's good. So let's rewrite these fractions. So I got 1 over 45xy cubed plus, give yourself a little space here, 1 over 35x cubed yz. All right, what do I need to multiply this, top and bottom, to get to my LCD? I need to multiply by 7x squared z, 7x squared z. And this one, top and bottom, what I need to multiply by? I need to multiply by 3 squared y squared. So basically I need to multiply by 9y squared, 9y squared. All right, let's see if this is true. I feel like I'm feeling not confident, like I made a mistake here. But if I do, that's fine. I'll just re-record this and pretend it never happened. 4 times 7 is 45. That's 45. Oh, sorry, I'm getting a call. Ignore that. Okay. I'm not re-recording this one. 45 times 7. Let's check it out. 45 times 7. 315. Yay! So we got 7x squared z, and we have 315 x cubed y cubed z. Okay, plus 9 times 35. 9 times 35 is 315. Looks like I might have done that one right as well. And we got 9y squared over 315. And we have x cubed. Y times y squared is y cubed and z. Do we have an LCD? We do. They're both the same. Combine the fractions, put them on top. So we got 7x squared z plus 9y squared over 315 x cubed y cubed z. Good times. Okay, so let's go through these steps right here. You found the LCD using the system above, all right? The one right above your paper, right there, right? And then we found the missing factors. Okay, so we found these missing factors, right? What do I need to multiply to get to the LCD, the missing factors? It helps if you list the factors of the LCD and you find which ones are missing here. So in this one, 7 was missing. We only had 1x. We need to have x cubed, so I put an x squared. All right. So you find the missing factors. You multiply each fraction by the missing fractions. All right. Multiply each fraction by missing factors. That's its factors. And did that top and bottom. And add and subtract numerators. All right. Just add the numerators. You guys already know that. And you keep the denominators. All right. I believe right now we are going to do some practice problems. So go ahead and start the practice problems, and I will see you guys on Monday. I'll be thinking about you. I'm sure I'll be thinking about you. I'll miss you guys. I'll probably think about you for at least 30 seconds before I get distracted by something else. But those 30 seconds will probably be agonizing for maybe 20 seconds, and I'll get over it. But I hope you guys have a great weekend, and I hope you're having a great math period. Bye.